So welcome everyone. Thanks for your time. Probably you spent your afternoon here, and I would like you to be most beneficial from this meeting as much as possible. So let's get started. So the topic for today is introduction to generative AI with open source large language models. I'm Michał Bryś. I'm machine learning architect at GetInData. Here you can find also the contact for me later if you have any questions or any ideas, or you just like to discuss something about generative AI and machine learning in general. I'm professional data engineer for Google Cloud Platform and also machine learning engineer certified for machine learning in Google Cloud Platform. Also, I recently became Google Cloud Authorized Trainer. So as you can see, my area of expertise is Google Cloud Platform and machine learning applications. The topic for today is generative AI. So let's start with some quick introduction, because some of you may notice, like last year, almost a year ago, because it was in November 2022, the big generative AI rush started. So there was a lot of articles on the business press, on the news, on the economy, and so on, that generative AI is changing creative work. So many questions raised, how my work will look like after this new technology. And that question was asked by writers, painters, even software engineers and data analysts, by everyone who do some creative work. Of course, that question was in good place, because in late November in 2022, OpenAI company introduced ChatGPT and made that technology available for average Joe, because it was really easy access to that large language model, available from web UI. Everyone who has access to the internet and the internet browser could log in and interact with that model and chat, ask questions, get responses. So it was kind of groundbreaking innovation and new technology which will change the market. But this is only one point of view, because the generative AI started not in 2022, because it started much more earlier. You can see this is really fresh, still really fresh technology, but it started earlier. Looking back to 2010, there was first models about near perfect translation of the natural language. So this was the foundation for the future progress in the technology of generative AI. 2010. Next, 2014, there was new models which were mastering the meaning of the words. So it was about interpret text, do some meaning, not only the words as a string of bytes. In the next 4 to 7 years, there was a big progress on large language foundation models. Large language foundation models are the models which was trained on the large amount of data, and that models can do some out-of-the-box task operations like text summarizations, question and answering, natural translation, and so on. And also that models can be customized to the task-specific purposes, only with some additional data, but that models required only small additional data to achieve the state-of-the-art performance on the new tasks. This is something called transfer learning. And at the end of the 2022, the conventional large language foundation models arose with the ChatGPT released and make it available to the public. So you can see it's the last 12 years of progress and building new technologies. Of course, the ground for that technology is kind of machine learning models and so on was created many years earlier. But you can see GPT technology is not from the last year, but this is the evolutionary way of the generative AI models through last at least 12 years. Here on that chart, you can see also that GPT is only the example of large language models, because on that timeline, which starts on 2018, you can observe like different types of models in the generative AI, and especially on the text field. So you can see decoder only branch, and you can see what kind of models are on that branch. There are encoder, decoder kind of models, encoder only, and a few minor things. So you can observe also like many models on the generative AI for text were created. Also many serious companies were created this and supports, and even build their own and give it back to the community models. So you can see also large language models are in the really dynamic growth, and really are progressing really, really fast, because you can see also that each year brings more and more models and new versions of that models. But what is the generative AI in general? So generative AI or generative artificial intelligence refers to the use of AI to create new content like text, images, music, audio, and videos. And generative AI is powered also by the foundation models, like large AI models, that can include and perform out-of-the-box tasks on text, like summarization, Q&A, classification, and more. And also with that minimal additional amount of data, that models could be adopted to targeted use cases using transfer learning. So this is one example definition of the generative AI. But for you, probably will be more important that what can we do with generative AI? So we can do something for text. So like I mentioned a second ago, there are text operations, including this one, including sentiment analysis and so on. And then we can make us one more step, because generative AI may be the conversational interface to the other systems. I mean, with large language models, you can generate code like Python, Java. You can generate SQL query based on the natural language. So you type your query in the natural language, like plain English, and that model will translate your language to the SQL query to execute on the database. So this is really, really interesting thing. We can do one more step. So we can build the private personal assistant with the custom knowledge base. So you can plug some external knowledge source, like your private database, the database or the scientific articles, the database or your private research, and you can chat with that data set through the generative AI and large language model. You can summarize that data, you can generate question answering, and so on, based on that custom knowledge base. So we can see that this is really interesting fact, and speaking about the technology, it's like breaking news and breaking change for the future technology development. But generative AI is not only about the text, because with another models, you can even generate images from text descriptions. This is the example of that graphic. I asked the model to paint the capabilities of the generative AI, and it produced something like this. So you can see that this is also something good for fun, but I find it really useful for the marketing creation, for graphic creations, for presentations, and so on. But it's not only about graphics, because you can see even the recently released model to craft the audio from the text description. So you can see like Meta company released AudioCraft, which is the generative AI tool for audio and music. So you can type like, okay, please generate electronic Jamaican reggae DJ set, and it will create that music based on your prompt. So this is really impressive technology, and you may even spot the internet radio with the generative AI only. So there is music generated by generative AI, audio news and like programs based on the generative AI generated text translated to speech. So this is really impressive, and I'm really interested in like what will be next and what's possible with the technology. That was maybe fun use cases, but now let's go to the real world use cases of generative AI. So in the next slides, I listed a few use cases for the generative AI. You can spot surfing on the internet using different applications. So first thing, you can even navigate to that place now. There is a website called Open Source Insights, and there is the Data Explorer tab where you can interact with the statistics about GitHub repositories by the natural language. So you can see here in the Data Explorer tab, you can type your question in plain English, like select companies who are using Kedro framework, which we are using also in my team, the MLOps labs. So you can just ask for the companies who are using that framework in their code, which is present on the GitHub. That system will use generative AI and large language model to translate that question to the SQL query. And that system also will translate that question to the SQL query, send it query to the database with the statistics about GitHub repositories. It will return the answer in the table format, and you can even plot that data from the results as a chart. So this is quite impressive. In theory, you may think like, okay, no more education and learning for data analysts is required because we can do everything by the generative AI. In theory, in practice, if you will try that tool, you will see that it's still not perfect. Sometimes it generates SQL queries which are like with errors, or which will give you no data and so on. But I encourage you to play with this tool, and you will see what's the advantages and also what kind of errors it may produce. It's still new technology, but I encourage you to test it. The second place where you can find the generative AI application is the code generation assistant. For example, in GitHub, you may enable the feature called Copilot, and that feature will help you to write actual code, in this case, Python code. How it works? It works this way, like you start the Python function definition, you put the function name, you put the input parameters, and then you just describe in plain English how that function should behave. What are the inputs? What is the expected output? And after that specification provided by the human, the system will generate the actual Python code to realize that requirements. Also, you can see that probably the human in the loop is still required here, and the results requires some review by the human, but still this kind of functionality can speed up the software engineering process a few times. So I encourage you to also to play with that tool. Another real-world example are the task-specific models, because like we said, we talk about foundation models, which are good for the general task-specific things, but also some areas, some industries requires a little bit more domain knowledge. Like here in this example, the Bloomberg company created their own large language model trained on the financial data and trained also for the financial tasks. So you can see like there is general model and also the domain specific knowledge inside, and you might discuss and you might ask questions about some stock market, some financial data, some market cap, and so on, some different economic metrics. You may ask to generate summaries, documents, and so on to that model. And that model will produce high quality responses because it's fine-tuned for that use cases and that specific tasks. And now it's time to talk a little bit more about large language models itself. So you might be curious, like how that large language models are trained. So here is the example of the training process for the GPT model. This is from the OpenAI research blog. So GPT model is trained the 3 steps. So first step is to collect demonstration data and train a supervised policy. This works like there is a data set with the prompt engineer, with the prompts, which we feed to the model later. So we get the prompt, and we've got human in the loop here. So we get the prompt as a model input and the labeler who demonstrate the desired output behavior of that model. He or she writes it down, and on top of this, we've got the that data used for fine-tuning of GPT models with supervised learning, where the input was from the dataset, but the output and the labels were created by the human. In the second step, we collect the comparison data and train a reward model. So it works this way, like we send the prompt, the different models, we collect that responses from the model, and then again we've got human in the loop, a labeler who ranks the output from the best to worst, and on top of this we can train a reward model we will use later in the step number 3. So step number 3 is to optimize a policy against the reward model using reinforcement learning. So we've got running large language models. When the users put prompts, we get the responses, and once upon a time we've got a reward model running on that outputs, where we put a reward to the good responses, and we can feed that rewards again to the model. So it will promote the good responses later. You can see like this is not the thing which could be done by average Joe on the laptop or even on the small virtual machine on the cloud. It requires specific knowledge how to do this. It requires specific data set for model training, and also it requires a massive compute infrastructure and cost, like big infrastructure costs. So this is not the thing for everyone, but on the other hand, we've got also some other points of view, like this is the article from the Nature, that the conservative view is that large language models are very good at next word prediction, and that predictions are unrelated to any real understanding of the language. So we can see like we've got really sophisticated technology and really complex model, and at the end of the day some people says that okay, they are good in predicting the next word, but you will see that as the technology grows and we get more and more complex models, and that technology learns to solve more complex problems, you will see that maybe it is something more than next word prediction. Here, speaking about technology, so here you can see some example list of large language models available from through ChatGPT. ChatGPT for all Python package. So we can see different models here, and the file names. This is the technical information, but the most important thing is here. So we can see like that open source models are in size from a few megabytes to a few gigabytes, like that model trained and even optimized for inference still has like 8 gigabytes of data, even almost 18 gigabytes of data. So you can see like not every laptop or local machine, even virtual machine will fit this. Also, to serve that models and to interact with that models, we need also the RAM memory. So also 7 gigabytes of disk for the model itself, but to work with that model, we need, for example, 16 gigabytes of RAM memory. So you can see like that technology should be really complex under the hood. And if you want to interact with this technology on your rules, on your hardware, you need to be prepared. Like, okay, you need some big machine. But hopefully there are like different ways how to interact with this model and how to use them. So this is really simplified technology landscape. This is like really opinionated and my perspective, but as a regular data scientist or data analyst or software engineer, you've got two ways how to approach and how to use generative AI models. So first option, you can use proprietary models available as a service, like through the user interface on the web or through the API. Two examples, like ChatGPT or Palm models provided by Google. So you cannot possess the model, you cannot own it. You can only use it because it's trained and stored and deployed on some vendor infrastructure. But also you don't have to take care about maintaining that model's deployment, costs of infrastructure, cost of training, and so on. So you've got that model available somewhere on the cloud, and you can interact with that model by sending the data, sending prompt through web UI or sending the request over the internet through the API endpoint. You send the prompt and the data, you get the response, and this is also how you can you will be charged for that model usage. Another approach is to use open source foundation model and deploy that model on your hardware, your infrastructure, like on the private way, on your rules. Of course, you will get more responsibilities about maintaining that model, about updating that model, model infrastructure for deployment, usually because you will not train this model by your own. So this is another approach. And also here we've got some options. We've got quite good models called Llama, released by Meta AI. There are good models from Microsoft called Orca. There is like really good and well-performing model called Falcon. So you've got option to download that model and deploy this to the system you want to use it. As large language models are still fresh technology, there are open challenges in that large language models research. So there is not comprehensive list, but mentioning only a few. Like still there are challenges how to approach to reducing and measuring model hallucinations, because you will see sometimes you ask about thing A and you will get the response about thing B. Seems still like really confident answer from the model, but it will be like unrelated to the initial question. Then another challenge, like number 4, is to how to make large language models faster and cheaper, because you will see like even if we spin up some really powerful compute machine, generating text from that model takes time. Of course, that large compute machines are not so cheap because you need to pay for the infrastructure, and even if you want to calculate how to calculate the cost of model training, like from scratch, it's like hundreds or thousands of dollars, and not everyone may approach to and afford to that spend. The last thing is also how to build large language models for non-English languages, because you can see like most popular models are trained on the English language. Of course, you can interact with that models through the other languages, but also then there is like additional step of translation, and you may notice that something will be lost in the translation in that process. So this is the list of open challenges in the large language models research. Also, I recommend you to find the source article on the chip block. Then, before we get started and we will make our hands dirty with the data and the practical exercises, there is one more thing, because before you will feed your sensitive data, your company data, to some external system, you need to think about privacy and compliance for generative AI. So here is the quick list of what you should think about before using generative AI in general. So you should think about, is your data needed to leave your infrastructure? How about the information security during transfer, during storage in the target place? So you need to think about this. The second thing you should address is your data will be used for future model training, because you may see like the vendor of that model, of that service, may record your prompt and your responses from the model, and they may use that data for the training of next generations of that model. So there is a risk of your business secrets and sensitive information leakage. The third step is how about the license of the model? Because you can see like there are really good open source models released. They produce really good resources, but you should always check the model license, because not every model is allowed to be used in the commercial applications. And the fourth, maybe the last aspect you should be aware is how about the responsibility for the generated content? Because if generative AI model will generate, for example, some text, and someone will take decision based on that text, and it will be wrong, for example, so how about the responsibility for that decision? So these are still open questions for generative AI. Okay, so that's the theory. So now let's spend a few minutes in practicing. So in a second, I will demonstrate you the use case of summarization of the financial data. And hopefully you can reproduce that exercise later on your own computers and on your own web browsers. So I will post the link to that notebook later on the chat at the end. Yes, we need to have some high-level perspective, like how we can interact with large language model and what we will need. So first, we need the prompt. So this is the text input to our model. The second thing is the model parameters, because we need to tune a little bit the model behavior, and we may make it better for our use case. And with prompt and model parameters, we can call large language model to get the output. So this is really the eagle eye perspective. What the parameters mean. Because prompt is simple. Prompt is the text input to the model, like please generate something. And the model parameters are a really interesting thing, because you can set the model temperature. And the model temperature means like the larger values increase creativity of the model, but decrease factuality. So the higher temperature you will set, the model will be more creative, but may produce also the more unrelated responses to your questions. Another example is the maximum of tokens. So you may limit the size of the answer that model will return. It means number of tokens to generate. Then you can set the top K. So top K means you instruct the model to randomly sample from the top K most likely tokens at each generation step. And top P is the parameter that you instruct to the model to randomly sample at each generation step from the top mostly likely tokens, which probabilities adds up to top P. You may play with this parameters later. And how we can interact with that LLM's models, like practically. So there are three main options. First option, you may download the desktop application, for example, GPT for all. In that application, you may interact with open source model. You may download that model or models from the internet to your computer. And the second option is also to interact with the third-party applications, also through that interface. So you should obtain the API key, and you may call even ChatGPT from your interface through API. So this is the first option, desktop application. The second option to interact with large language models is to interact with them programmatically through the, for example, Python language and Python packages, through sending requests to the APIs, and so on. You might do this from the console, from the Jupyter notebook, from Colab notebook, and so on. And we will work on that option in our use case. And the first option to interact with the model is to use the third-party services. So, for example, here is the Vertex AI Generative AI Studio. So there is a web interface where you can go. You can open the tab, select the model, put your prompt, set the parameters, like on the right-hand side, and set the parameters of the model, and you can get the answer. So practically, there are three ways to interact with the large language models. And now it's time for practice and for our use case. For that use case, we will use a few things. First thing is the Google Colab. So for those who are not familiar with this solution, Google Colab is a hosted Jupyter notebook service that requires no setup to use and provide free access to computing resources, including GPUs and TPUs. Of course, in the free version, the compute resources are not guaranteed, so you will need to wait sometimes to execute your code. But it's free to use, and you may reproduce that exercise later today. I will be using the premium version of Colab because it guarantees the compute resources, and I would like just to save your time during the webinar, just to not wait too long for the responses. Of course, as you remember, the model size and the required operational memory for that models, also having the premium version, it helps us to get the resources because we will get a lot of RAM memory available. So first thing, Google Colab. Second thing, GPT for all. So GPT for all is the, let's say, platform and set of tools and this is the interface for large language models. It's free to use. You can run it locally. You can run it on your virtual machine somewhere. You may run it on the private cloud and so on. There is no GPU or internet required to run it because you can download the application from the internet, the interface, download the model, then you can plug off your internet connection and you may use it. So it's good for that from that perspective, and you can interact with open source large language models on your own hardware, and even you may interact with the third-party applications by providing your API to access, for example, ChatGPT. So you've got the single interface for different large language models. Hopefully, we've got the desktop clients for Windows, for Mac, and for Linux users. And we've got also the Python package we will use in our exercise later. So what's the scenario? So our scenario for that task is that we have an example financial report with the data in the table format. We put some command in front of that data that this is the historical data about the revenue of the e-commerce company, and we would like to create some executive summary of this data with some basic insights to share that insights with the stakeholders. So yes, now I will switch the windows. I'm sharing with you. There we go. So now you should see the Colab interface, and I will walk through the instruction I'm sending to that system, and you can observe the results. So first, I need to install that GPT for all Python package. Okay, there we go. I will make sure that I'm using the right environment. So I've got the high RAM machine with 51 gigabytes of RAM available and more than 200 gigabytes of disk available. So that's quite a lot. You can run the same also on the free version. No worries, you will just need to wait more if the no resources are available. Okay, so let's start. So now I will import the GPT for all Python package, and I will list the available models here. So let's check what's available. Then I will print. Okay, so here is the list of the models in the JSON file. I will not walk through each column because it's also in the not too nice format, but you can see here the contents of that file. What's important? You've got a list of the models ready to use by GPT for all. Each model has a name, has a file size, has a required RAM, number of parameters you use, and also the description. And in the description, you can see the most critical information, like that model cannot be used commercially, or that model is ready to the commercial use case. Description. Licensed for commercial use, for example. Unfortunately, you need to manually check that information on the model description, but this is most critical part of the model list. So you can find the model license on that JSON file. I will print also the quick summary of the model list here, just to extract the best information, the most important information. Also, I put this on the slide. So we've got model name, file size, RAM required, and number of parameters. And you can see some of that models are trained on the 13 billion parameters, some of them on 7, some of them on 1 million, for example. But you can see the correlation between the number of parameters of the model and the model size and the RAM required to run for the model. You can even see there are larger models. I mean, for example, the latest version of Falcon model contains 180 billion parameters. So you may imagine, like, there is no virtual machine which will handle this for you. But yes, there are larger models than this. So this is what's available on the GPT for all. And we will play with a few models which are allowed to use commercially now. So we've got the model, and we need also the prompt. So prompt is the text input for the model. So we can see, like, I put here some description of what's inside of that table. I help also the model to understand the data because I described the data format. So this is the markdown table. Here is the actual data. And at the end, I put the instruction, what I want to do with this data. So let's start with the executive summary generation with the model 1. The first model, this is the model called Llama 2, and it's trained on the 7 billion parameters. So in this step, now you specify the file name of the model. If that model is already on the disk, it will read that model from the cache data. If it's not, it will download that model from the internet. So yes, it will. This step may take some time, and then there is a stage of the prompt and the response generation. So now we are waiting for generation of the text based on that prompt on the model. So it may take some time, up to a few minutes. So I will also run the next cells. And now we need to wait just for the first one. For the second one, I've got the results in cache on the second tab. Maybe there are some questions on the chat. We may start to answer while we are waiting. Okay, no questions, but yes, now you can see that there is an answer. So it took some time, even on that powerful machine. We may track also here. So now it's 7 gigabytes of RAM, but previously you can see like it was a spike on the memory use. Yes, and you may get the response. So the response from that model is that based on the provided e-commerce company revenue data, here is a brief executive summary. And here is the text which is describing that data set. You can see like this is like really verbose, so a lot of words, a lot of sentences. So let's give a few seconds for the next model just to complete the text generation. And we can just preview the output from the other models just to not keep you busy waiting for the model output. Now it works, and you may see the results from other models. So we will go back to the Jupyter notebook in a second, but here I created the summary of the different models answers generated for that data, and now we can walk through and we can compare like where the model is correct, where the model is not correct. So we can see here the results for the model called Llama 2, 7 billion parameters. You can see this answer really similar to that we've seen on the Jupyter notebook. And you can see also that speaking about the numbers, that model was sometimes correct and sometimes not correct. So you may see that there is a jump in 2005. This is correct because the jump was almost 10 times in the 2000, and the increase one in the 2010. This is okay, but also that model points that the highest revenue recorded was 700,000 in 2009. So the number is correct, but this is not the highest value. So the actual value of the revenue in the year is correct, but also you can see like the highest was not in 2009, but 2010. So you can see like always when you use large language models, you have to do the fact check if the numbers are correct and if there is no hallucination. So this was Llama. Another model was the model called Falcon. And here you can see the example of model hallucination, because the data covers only the data from 2001 to 2010, and the executive summary says like we've got the data from 2001 to 2020. So the model added 10 extra year of data. The model created also something which we cannot see on the input table, like units sold. We don't have this data in the table. Also, we've got some analysis of the data from 2017, which is not presented in the table. We've got even some kind of interpretation of the meaning of the data, that some setbacks during the pandemic with an decreased revenue in 2020 due to the COVID outbreak. Remember, we've got only data to the 2010. So this is the example of the model hallucination. So even if it's like really verbose, there is a long block of text, you have to double check what's inside and what are the results. Another example is the ORCA model. Again, 7 billion parameters. So we've got some good things, some bad things, because this is one company, and we explicitly said that this is one company, and the model produced a summary for different companies. Also, we've got wrong value. I mean, the numbers are correct, but the highest was not in 2009, but 2010. And the lowest value is also from, okay, so this is also not correct, because it should be in 2010, the lowest value. Another model, the smaller one, so the ORCA model with only 3 billion parameters, you can see like that model produced the shorter executive summary, which is correct, but this is not so really informative, because this is really general. 3 billion parameters, and another model with 13 billion parameters. So this is twice larger, almost twice larger than the Llama model, for example. So it created also the management summary, not so long, but the correct in terms of numbers. So let's go back to our tab, and you can see like it took 1 to 2 minutes to produce the response for the model. They are different for the model, but you can also see like some model created some more informative things and longer block of text. Some models created shorter answers, and so on. Okay, so now it runs the largest model. Okay, it took 2 minutes, and it takes 2 minutes, and we've got the results. Okay, so that was the text summary. And as a bonus, because we are getting almost to the end, so for the bonus, I prepared some other use case, because based on that data, I asked the model to generate not the executive summary, but to generate the Python code to visualize that table in the linear plot. So let's see how the model, I decided to go with the Falcon model. So let's see what kind of code that model will generate, and if we can use it like copy paste. So let's give it a second. Below I've got some previous run, but let's say what kind of code it will generate. While we are waiting, I see 2 messages. Okay. So I see one question about the recording. So yes, Claudia will distribute this to you, probably by email. So you will get the notification about when it will be available. And let's give it a second. Let's wait until 2 minutes, let's say, so 15 seconds, and okay. There we go. So you can see the answer from the model. So to create a line chart using matplotlib, you can use the line2D class from matplotlib lines module. Here's an example code. Yes, so this code generated. So I will copy this thing. I will keep the code generated in the previous one, but let's say. So we need to import pandas, matplotlib. We need to import data from the CSV file. I created that file here, or it was deleted. Okay. So I've got. I will just copy that file from the other project because. Okay. So we need the CSV file with the data inside of the markdown table here. So this is the same like on the input. So we need that CSV file. We've got revenue here and revenue. Okay, so this is the moment of truth. So we will see if it works. Yes, it works. And it generated the plot. Probably we expect the other order of the data, like revenue here and the year on the X, and sorry, the revenue on Y axis and the year on the X axis. So the model mismatched a little bit. The meaning of the columns, but if we will replace the order, so this is kind of on the first view, I see that it may be correct. So we may see like even that large language model may even produce the code which will work something like copy paste. In the previous run, that code did something weird because in the model added a line that convert the column names to uppercase for plotting. So the model added that line, and I had to manually uppercase the column names to make that code working. But yes, it generated that kind of chart too. Great. So that was it from my side. So just to summarize our meeting today quickly. So first, you can see like availability of that large language models increased in the last months, exactly with the open source model, with the models, with the third-party services that host the model for you. Also, you may spot that everyone has access to the same models. So the winner in case of business will be the company who will find the right business use case for the large language model, and maybe even fine-tune that model to some specific tasks. But you can see this technology is available like for almost everyone. And that technology is the same. And also, you should remember that large language models are still on the early stage of development. So maybe even you can see like it will bring no value today, but you should be ready to adopt the models in your workflows in the future. If you are interested in reading more about use cases of large language models and generative AI, you may check our blog, where we've got recently published a few use cases about building shopping assistant for the e-commerce store, or even how to build reading assistant using Kedro and Streamlit. If you are interested in some consultation or some discussion about generative AI, just remember that you may write to the email hello@getindata.com, and someone from our team will contact with you. And now let's give you a few seconds to take a feedback, to write a feedback for that webinar. So Claudia, please copy the message in the chat with the link. In this time, I will also provide you with the link to that notebook, which you can copy and use on the Google Colab. So as a thank you for the feedback, I just posted the link to the notebook. You can just use on your own Google Colab instance. And just a few things at the end. So soon, next week in Gdańsk, in Poland, we organize the Data Mass Gdańsk Summit. This is the industry conference focused on the cloud applications. We will be holding also generative AI workshop with my colleagues Piotr and Marek. So if you are interested, there are, as far as I know, there are still some free places for that. So consider to sign up. There is also a discount code for the webinar participants with that special code. So just think about like joining us next week. Also, my colleague Marek will hold the presentation on the day of the conference. So I hope that we will see each other next week in person. Just if you are curious about MLOps, because before generative AI, the most hot topic was the MLOps thing. So we've got some free ebook about MLOps. So also you may download that ebook from our website. So thanks for your time. Let's check for the questions, because we've got time to answer one or two. So I will check the chat for the questions. Okay, so if there are no questions, so thank you for your time. I hope you enjoyed the webinar, and see you soon.